Have you ever wondered if Earth might be the luckiest planet in the entire universe? For decades, scientists have searched the skies for signs of intelligent life. We've discovered thousands of planets orbiting distant stars, and today we know that planets are incredibly common. Looking at the numbers alone, it almost seems impossible that humanity could be alone. Yet despite decades of searching, we've never found a single confirmed alien civilization. No radio messages, no giant megastructures, no alien spacecraft, nothing. Well, one possible explanation is called the rare Earth hypothesis. And if it's correct, then intelligent life may be so unbelievably unlikely that we could be one of the only technological civilizations in the entire observable universe. Today, we're going to find out why. At first glance, the universe looks almost designed for life. The Milky Way alone contains somewhere between 100 and 400 billion stars. Astronomers now believe that most of those stars have planets. Across the observable universe, that means there are likely trillions upon trillions of worlds. Even if only a tiny fraction of those planets could support life, there should still be millions of inhabited worlds. So why haven't we found any? This mystery became famous after physicist Enrico Fermi asked a remarkably simple question during lunch with his colleagues: "Where is everybody?" Today, we call this the Fermi Paradox. If intelligent civilizations are common, then many of them should be millions, or even billions of years older than humanity. Given enough time, an advanced civilization could spread throughout an entire galaxy. The Milky Way is over 13 billion years old. So if alien civilizations are everywhere, someone should already be here. One possible answer is the rare Earth hypothesis. Unlike many other explanations for the Fermi Paradox, the rare Earth hypothesis doesn't claim that life never appears. In fact, it suggests that simple life, tiny organisms like bacteria, might actually be fairly common throughout the universe. The real problem comes later. According to the rare Earth hypothesis, evolving from simple cells into intelligent beings capable of building telescopes, computers, and spacecraft requires an extraordinary sequence of incredibly unlikely events. Miss just one of those events, and intelligent life may never appear. The first requirement is surprisingly easy to overlook. You need the right kind of star. Large stars burn incredibly hot, but they also die young. Some explode as supernovae after only a few million years, far too quickly for intelligent life to evolve. Smaller red, dwarf stars live much longer, but many produce violent stellar flares capable of stripping away a planet's atmosphere. Our Sun sits in a remarkably stable middle ground. It's massive enough to provide energy for billions of years, yet calm enough to allow life to develop. According to the rare Earth hypothesis, stars like our Sun may already eliminate countless planets from the search for intelligent life. But finding the right star isn't enough. You also need the right planet. Earth isn't too close to the Sun, where water would instantly evaporate. It isn't too far away, where everything would freeze solid. Instead, our planet orbits within the habitable zone, where liquid water can exist for billions of years. Earth is also just the right size. Its gravity is strong enough to hold a thick atmosphere, but not so strong that the surface becomes uninhabitable. We also have a powerful magnetic field that protects us from harmful radiation streaming from the Sun. The rare Earth hypothesis argues that a planet with all of these characteristics may be far rarer than we once imagined. Earth's list of advantages doesn't end there. Our planet has active plate tectonics that recycle carbon through the atmosphere, helping stabilize Earth's climate over millions of years. We also have an unusually large moon, which keeps Earth's rotation remarkably stable. Without it, our planet's tilt could change dramatically, leading to chaotic climate shifts that might make complex life far more difficult to sustain. When you look at each requirement individually, none of them seems impossible. But the rare Earth hypothesis asks a different question. What happens when all of these unlikely requirements have to occur on the same planet at the same time? The answer may completely change how we think about our place in the universe. By now, the odds are already starting to look discouraging. But the rare Earth hypothesis doesn't stop with stars, planets, and moons. It argues that intelligent life depends on an entire chain of rare events, happening in exactly the right order. Ugh. Earth's atmosphere has remained stable for billions of years. Massive asteroid impacts have been rare enough to avoid wiping out life completely, yet common enough to accelerate evolution. Even Jupiter may have helped shape our solar system by altering the paths of countless comets and asteroids. None of these conditions guarantees intelligent life, but without them, Earth might have looked very different. Perhaps the biggest assumption we make is believing that life naturally becomes intelligent, but Earth's own history tells a different story. Life appeared on our planet nearly 4 billion years ago. Yet for most of that time, Earth was inhabited only by simple, single-celled organisms. Complex animals didn't appear until relatively recently, and technological intelligence emerged only within the last few 100,000 years. According to the rare Earth hypothesis, intelligence may not be the inevitable outcome of evolution, it might simply be an extraordinary accident. This leads to a fascinating possibility. Maybe the universe is filled with life. Perhaps countless planets are covered with oceans containing microscopic organisms. Some worlds may even have forests, strange animals, or ecosystems completely unlike anything on Earth. But none of those worlds ever develop science. None build radios, none launch spacecraft, none look up at the stars and ask whether they're alone. The rare Earth, or hypothesis, doesn't necessarily predict an empty universe. It predicts a silent one. If the rare Earth hypothesis is correct, then humanity may be living on one of the rarest planets ever to exist. Every requirement we've discussed, the right star, the right orbit, the right planet, a stable climate, a magnetic field, plate tectonics, and a large moon, may represent another filter that most planets never pass. Individually, each requirement seems possible. Together, they may be extraordinarily unlikely. Perhaps Earth didn't just get lucky once. Perhaps it won the cosmic lottery again and again. Of course, not every scientist agrees. Some researchers argue that we're drawing conclusions from a sample size of exactly one planet. Earth is the only world we currently know that supports life. Until we discover life somewhere else, we simply don't know which conditions are essential and which are merely coincidences. Future discoveries could completely change the picture. Perhaps life adapts far more easily than we imagine. Or perhaps the rare Earth hypothesis will become even stronger as we learn more about planets beyond our solar system. Right now, nobody knows. The rare Earth hypothesis remains one of the most fascinating ideas in modern astronomy because it forces us to ask a profound question. Are we ordinary? Or are we unimaginably rare? Somewhere out there, beyond billions of stars and trillions of planets, another civilization may already exist. Or perhaps the night sky is silent because intelligent life is one of the rarest phenomena the universe has ever produced. We simply don't know the answer. But until we do, every new planet we discover brings us one step closer to solving one of the greatest mysteries in science. I'm Tom, and next time we'll explore another incredible idea that might completely change the way you think about the universe.